is the position of a ship that is obtained by intersection of two or more position lines, intersection of two or more position circles, intersection of one position line and one position circle. I'm sure you would have watched the earlier videos on position lines and position circles and would by now be comfortable with the concept of PLs and PCs. Or a position that is obtained by a reliable electronic navigational aid like GPS, which may provide the position in its coordinates of latitude and longitude. A fixed position or an observed position is a confirmed or validated position. It's represented on the chart with a symbol of a dot and the circle surrounding it. The dot in the center represents the position of the ship. And if we want to indicate the time for which the fix has been marked, it can also be indicated against the symbol, as you can see on your screen out here.
Okay, so this is the fix of the ship, beta. Any doubt up to here?
No, sir.
No, sir.
Okay, very good.
The next one is DR position or the dead reckoning position, which is obtained by factoring in only the ship's displacement caused because of the course she steered and the engine distance that she has covered from a last known fix. So to mark the DR of the vessel, we must know the last known fix. We must know the course or courses steered during that interval since the last known fix and the engine distance that has been covered. DR position on the chart is represented by a cross. And if the time has to be represented for the DR, it can also be marked next to the symbol. DR position does not factor in effect of any external force like current or wind experienced by the ship.
This is also clear, beta. Any doubts?
No, sir.
Very good.
The next is estimated position. It is the position obtained by factoring in ship's displacement because of the course steered, engine distance covered, together with the estimated current and or wind that may have been experienced by the vessel during that interval. EP on the chart is marked with a triangle or a square with a dot in the center. And if the time has to be indicated, that can also be mentioned against the symbol. EP factors in the estimated effect of current and wind experienced by the vessel. So now, amongst all these, undoubtedly, an observed position or the fix of the vessel is the actual position of the vessel that has been observed by definitive position fixing means. Next in the order of accuracy would be the estimated position, and last would be the DR position. We shall be using these positions depending on the information that is available in the same order of accuracy. If we have a choice, fix would be of the first topmost priority, followed by EP, and if none of them are available, we would use the DR position.
So any doubts up to here, beta?
सर एक बात पूछनी थी.
हाँ बोलो
जैसे
बेटा.
आपने करंट ट्रायंगल जो बनाया था सर,
अभी उस पे आएंगे, अभी चलेंगे उस पे, अभी ट्रायंगल सामने आ जाएगा.
जैसे आपने लास्ट क्लास में जो बताया था सर, जैसे जो जितना भी करंट लग रहा है, तो हमने क्या किया था कि डीआर पोजीशन को और अपन एस्टिमेटेड पे ले आए थे बिकॉज ऑफ करंट.
डीआर को एस्टिमेटेड पे नहीं लाए थे, डीआर तो वही था. डीआर पोजीशन पे करंट को जब लगाते हैं तो एस्टिमेटेड पोजीशन मिल जाती है.
ओके सर, तो मतलब आपने बताया था कि विदाउट विंड एंड करंट इफेक्ट जो पोजीशन जो कोर्स हम कर रहे हैं अलोंग विद द कोर्स, वो जो पोजीशन होगी किसी भी मतलब आवरली या 2 आवरली, दैट इज डीआर पोजीशन. और अगर उस पे करंट इफेक्ट लगेगा तो उससे जो पोजीशन नई वाली आएगी वो एस्टिमेटेड पोजीशन.
दैट्स राइट, वेरी गुड।
और उसके बाद में सर
बेटा तुम्हारी
जी मैं
आवाज ब्रेक ब्रेक हो रही बीच में।
मैं खुद कंफ्यूज हो गया सर। मैं बाद में पूछूंगा आपसे एक बार पढ़ के।
ओके बेटा, तुमने अभी तक जो बोला है वो बिल्कुल सही है, 100%।
ओके सर, मैं कुछ ठीक है सर, मैं बाद में पूछता हूँ आपसे।
नो प्रॉब्लम, जब डाउट आए तब पूछ लेना बेटा। ओके, लेट्स गो अहेड।
हाँ सर, हाँ तो जो जो एस्टिमेटेड आएगी उसी को फिक्स बोलेंगे सर।
हाँ बेटा, अब इसमें थोड़ा सा फर्क है। हाँ, देखो आपने CTS लगाया तो आपको DR मिल गई, करेक्ट।
करेक्ट सर।
आपने DR पे करंट भी अप्लाई कर दिया तो आपको एस्टिमेटेड पोजीशन मिल गई, करेक्ट।
करेक्ट सर।
अब बेटा ऐसा भी तो हो सकता है कि जो करंट आपने अप्लाई किया हो वो सही ना हो, क्योंकि करंट तो एस्टिमेटेड होता है ना।
यस सर, वो तो फिक्स नहीं है।
राइट, तो ऐसा पॉसिबल है अगर हमारे करंट में थोड़ी बहुत चेंज हो जाए, जो हमने लगाया है और जो एक्चुअल है दोनों अलग अलग हो जाएं, तो जो हमारी फिक्स है वो EP से दूर भी आ सकती है, दोनों अलग अलग जगह पे भी हो सकते हैं।
ओके सर। ओके सर, जैसे टाइम बिंग 1 आवर 2 नॉट का लगा और हाफ एन आवर मतलब नेक्स्ट 1 आवर 1 नॉट का लगा, तो करंट में डिफरेंस हो गया।
राइट राइट
ओके सर।
राइट।
ओके
ओके,
सर, थैंक यू सर।
सो ठीक है बेटा, लेट्स प्रोसीड अहेड नाउ।
Now let's understand the effect of current on the ship's track. What is current? Current is a continuous directed flow or movement of seawater because of varied causes like difference in temperature, difference in salinity, etc., etc. Moving seawater causes the displacement of objects floating in it as it carries them along. So the floating objects, which are freely floating in water, would be carried with the water as the water flows because of the current. In the absence of any external factor like current, ship's track or displacement over the ground shall be same as its displacement through water. So we must understand the difference between track through water and track over the ground.
ओके बेटा, यहाँ तक कोई डाउट? Okay, very good. So let's move ahead now. See it on the chart.
Difference between track through water and track over the ground. Now, let's understand this thing through the simple illustration. We have a vessel which is at position A at 0800 hours. It steers a course of 070 degrees true at an engine speed of 11 knots. There is no wind, no current, and we need to plot and obtain the DR of the vessel and the fix of the vessel at 1000 hours. So we plot the 0800 hours fix on the chart, as you can see. Now, from the last known fix, which is 0800 hours, if we apply the ship's displacement vector because of her own propulsion, that is the CTS and the engine distance, that shall give us the DR, as we have already discussed under the DR explanation. So from A, we draw the CTS of 070 degrees true. In Chartwork, the CTS is always marked with single arrow, and you please have to respect this convention of single arrow to represent the CTS line. On this CTS line, from A, if we mark off engine distance for 2 hours, which shall be 11 into 2, that is 22 miles, we get point B. Point B is obviously the DR at 1000 hours. Now, as there is no other displacement vector acting on the ship than her own propulsion, obviously her track over the ground would be same as the track through water. What we have plotted is the track through water, And in this case, the track over the ground shall also be the same. So actually the vessel would be at point B at 1000 hours. So this track over the ground is represented in Chartwork by course made good and distance made good. And this particular vector is represented by two arrows. You can see the two red arrows coming on the same track. That means track A to B, besides being a CTS track or track through water, is also a course made good track and track over ground.
So बेटा इसको ध्यान से देखो, ये समझ में आ गया? Any doubts up to here?
Sir, this is because there is no current and wind, that's why.
Right beta, that's right.
Okay, sir.
Okay, let's move ahead now.
So in this particular case, CMG is same as CTS, DMG, distance made good, is same as engine distance, and this position B happens to be the also fix of the vessel at 1000 hours. So position B is both DR as well as fix. Then we have track through water, which is represented by CTS and engine distance. And we have track over the ground represented by CMG and DMG, though both have been same in this particular case. Now, before we discuss the effect of current, we need to understand the terms that are used to describe current. The direction of the current is represented by what is called as set. Set is the direction in which the water flows. That is, if we say the current is setting south or current is setting 180 degrees true, that means the water is flowing from north to south. The rate of current is the speed of current. It is expressed in knots. The drift of the current is the distance through which a freely floating object at rest relative to sea water be drifted in a given period of time because of the current. Obviously, the drift, if we have to obtain in a certain period, it shall be equal to rate of the current in knots multiplied by time in hours, and what will get drift shall be in nautical miles. Now, with these terms having been discussed, let us look at effect of current on the ship's track.
This is clear beta, set of the current, rate and drift.
Yes, sir.
Okay, very good.
Now, with these terms having been discussed, let us look at effect of current on the ship's track. When the vessel steams, vessel experiences the displacement vector because of her propulsion, and this displacement vector because of her propulsion acts both through water as well as over the ground. And this displacement vector is represented by course to steer as its direction and engine distance as its magnitude. If this vector is applied to the last known fix, we have already discussed this, it shall give us the vessel's DR at the end of the steaming period. If the ship also experiences current, an additional force vector is caused, represented by set and drift during the interval. This additional force vector, because of the current, causes displacement only with respect to ground or over the ground and not through water, because the water and ship, they float together or drift together because of the current, and so there is no displacement of the ship in relation to water caused by the current. Thus, ship experiences two displacement vectors over the ground. Its track over the ground shall in such cases be along the resultant of the two vectors.
So any doubts up to here, beta?
सर पॉइंट नंबर 4 सर.
ओके, इसमें क्या डाउट आ रहा है बेटा?
सर ये कॉजेस डिस्प्लेसमेंट क्या मतलब किसके रिलेशन में बात कर रहे हैं सर ये लोग?
ओके बेटा, आप इसको ऐसे समझो कि हमारे शिप पे दो फोर्सेस अप्लाई हो रही हैं. एक तो है हमारे इंजन की फोर्स जो प्रोपेलर पीछे चल रहा है हमारे, और दूसरी है
Yes,
करंट
sir.
की फोर्स. दूसरी है करंट की फोर्स.
ओके
हमें
सर.
इन दोनों फोर्सेस का रिजल्टेंट निकालना है. इतना समझ में आ गया ना?
हाँ सर ठीक है, दो वेक्टर मान लीजिए.
बस बेटा डन है, इससे ज़्यादा और कुछ नहीं चाहिए. रेस्ट एवरीथिंग इज ओके.
ओके सर, दो वेक्टर निकाल लिए सर, उनका जो रिजल्टेंट निकाल लिया सर.
राइट, उनका रिजल्टेंट अभी निकालेंगे अगली स्लाइड में.
ओके सर.
ओके.
Let's try to see what we have just discussed through a simple example. We have a vessel at position A at 0800 hours. You can see on your charts. It steers a course of 070 degrees true at an engine speed of 11 knots. The vessel experienced current setting south at 3.8 knots. Now, by plotting, we need to obtain dr and fix. We have already seen in one of the earlier examples wherein there was no current or wind, the dr and fix at 1000 hours happen to be same. Let's see what happens in this particular case. Now, through A, if we plot our ship's displacement because of our propulsion, then that will be CTS drawn through A, represented by single vector, distance marked off for 2 hours 22 miles. Position B, this becomes the dr of the vessel at 1000 hours. This we have already discussed earlier as well. Now to see how does the current affect the vessel's displacement over the ground, for one time at least, let us split this into two distinct parts. Two displacement vectors, one because of ship's propulsion, other because of current, acting simultaneously, but let's assume they act one at a time, each acting for their respective 2 hours. So if only the ship's propulsion vector, CTS, and engine distance vector acts for 2 hours, then the vessel is expected to shift from or displace from position A to position B. So at 10 o'clock, you would expect the ship to be at B. Now, once at B, let us assume the engines are stopped. Ship is in complete rest in relation to the seawater, surrounding seawater. And now the current sets in, setting south at 3.8 knots. Now, as the water starts flowing southwards, the vessel would also drift southwards. So the vessel shall start drifting with over the ground in this direction as represented by the green vector. Now the green vector represented by 3 arrows is the current vector, and this is the standard 3 arrow notation that is used in Chartwork. If the vessel drifts for 2 hours, then she would have drifted through a distance of 3.8 into 2 equal to 7.6 miles, and she would reach point C. Now that means 2 hours of propulsion vector, 2 hours of current vector, both acting for 2 hours each. We expect the ship to reach point C. So C would be the position of the ship at the end of 4 hours in which both vectors have acted one by one. In our case, both these vectors are acting simultaneously. So both are acting for 2 hours each, but not one at a time, but simultaneously. So the effect would still be the same. And at the end of 2 hours, with both vectors acting simultaneously, the vessel would be expected to be at C. That means from 8 o'clock to 10 o'clock, so C becomes my fix at 1000 hours. From 8 o'clock to 1000 hours, the track over the ground would be represented by line AC. This track over the ground we refer to as course made good as its direction and distance made good as its magnitude. It's represented by two arrows. So now in chart work, the CTS vector is represented by one arrow, current vector is represented by three arrows, and course made good vector is represented by two arrows.
So beta, have a good look at the diagram. Let me know if you have doubts in any point.
सर एक बात पूछनी थी सर।
बोलो बेटा।
ये जो करंट लग रहा है जब अपन ए पॉइंट से चले सर बी पॉइंट के लिए,
राइट,
जब 8 बजे अपने जब पैसे चालू किया और 10 बजे हम बी पॉइंट पे पहुंच गए, तो जो करंट था वो थ्रू आउट लग रहा था। इसमें तो ऐसे बोल रहे हैं सर वो सर के जब अपने ए से गए बी तक और वहां पे जाके रुक गए और फिर उसके नेक्स्ट 2 आवर अपने को ये करंट लगा है।
ओके, वो बेटा इसलिए बोल रहे हैं ताकि ये चीज़ आसानी से समझ में आ जाए। अब जब भी हमारे पास दो वेक्टर होते हैं और हमें उनको ऐड करना होता है, चाहे वो दोनों एक साथ लगे, लेकिन उनको ऐड करने के टाइम पे एक के बाद दूसरे को ऐड किया जाता है। जैसा हमने स्कूल में भी +1 +2 में वेक्टर एडिशन में किया था। तो वेक्टर एडिशन की ये प्रॉपर्टी होती है कि चाहे वेक्टर एक साथ लग रहे हों, आप उनको किसी भी ऑर्डर में अप्लाई कर दो, किसी भी ऑर्डर में अप्लाई कर दो, उनका रिजल्टेंट सेम रहता है। तो आप बिल्कुल सही बोल रहे हो कि ये दोनों वेक्टर एक साथ लग रहे हैं, लेकिन उनको कंबाइन एक साथ नहीं किया जा सकता, इसलिए हमने एक के बाद दूसरे को लगाया है।
ओके सर, बट सर मेरा सवाल ये था, जो ये करंट है वो अपन ने पूरी वॉयज में फेस किया ना सर?
यस बेटा, दैट्स राइट।
ओके सर,
दैट्स राइट।
फिर सर वो 4 आवर क्यों बोला सर ने अभी?
4 आवर नहीं बेटा, 2 आवर्स। 2 घंटे के लिए ही हमारा CTS वेक्टर लगाया है हमने, और 2 घंटे के लिए ही करंट वेक्टर लगाया है।
ओके सर, नहीं अभी शायद मैंने सुना था 4 आवर बोला था सर एक जगह पे सर ने।
नहीं बेटा, 4 आवर्स यहाँ पे नहीं आ रहा है कहीं। इट इज़ 2 आवर्स, CTS वेक्टर फॉर 2 आवर्स, करंट वेक्टर फॉर 2 आवर्स, और जो तीसरा वेक्टर आया है A to C, जिसको हम कोर्स मेड गुड वेक्टर बोलते हैं, दैट इज ऑल्सो फॉर 2 आवर्स।
ओके सर, थैंक यू सर।
ओके, लेट्स मूव अहेड नाउ।
यस सर।
Now, the direction from A to C becomes course made good, which in this case is 091 degrees true, and the distance or magnitude of AC is 20.6, which is the distance made good. Since this 20.6 miles is the distance made good in 2 hours, so the speed made good would be 10.3 knots. So now please remember in this case that each side of this triangle is for the same duration. Here the engine distance was for 2 hours, drift was for 2 hours, so obviously this DMG would also be for 2 hours. So C is the fix at 1000 hours, B is the DR at 1000 hours, and the vessel's position will shift along the line AC, but her CTS does not change. CTS remains 070 degrees. So you see when the vessel reaches here, her heading is aligned in this direction, that is 070, but her position is shifting along this CMG line. When she reaches here, everywhere the heading is same as 070, but position is shifting along the CMG line.
So beta, this is also clear?
यस सर, बट सर एक बात पूछूं सर?
बोलो बेटा,
जो
पूछो।
लास्ट टाइम आपने दिखाया था सर, जो जैसे आपने लास्ट लेक्चर में जो आपने सेम कंडीशन था, सेम सिनेरियो था, लेकिन उसमें और इसमें चेंज क्या है सर?
जो बेटा पहले पहले हमने बिना करंट के देखा था उसमें और इसमें।
नहीं नहीं सर, जो लास्ट लेक्चर में अपन ने करंट के साथ भी देखा था ना सर, करंट एंगल,
हाँ हाँ,
वो और ये बिल्कुल एज इट इज सेम है सर।
या दैट्स राइट, दे आर सेम ओनली।
ओके सर।
दे आर सेम ओनली बेटा, यही चीज तो हमने पिछले लेक्चर में भी की थी, सेम थिंग।
ओके सर, मैं सोच रहा था सर इसमें कुछ डिफरेंट है क्या?
नहीं बेटा, नहीं नहीं, वो तो बोला कि सर हमने इसको रिपीट करना है एक बार, तो मैं दोबारा से रिपीट कर रहा हूँ। यही चीज हमने पिछले लेक्चर में भी देखी थी।
ओके सर, सॉरी सर।
ओके ओके, ऑल राइट, सो लेट्स मूव अहेड नाउ।
यस सर, प्लीज सर।
Yes, sir, please.
Now, let us look at a possibly different scenario. The vessel is at position A at 0800 hours. She needs to reach position C at 1000 hours. Position C is her destination position, could be anchorage, pilot boarding ground. Now, that means the vessel needs to make a track over the ground, which is represented by AC in 2 hours.
अब देखो बेटा, अब इसे ध्यान से समझना है आपने। जो इससे पिछली स्लाइड में हमने देखा था, हमें अपना CTS पता था कि हम 070 कोर्स स्टीयर कर रहे हैं, हमें करंट भी पता था और हमें अपनी फाइनल पोजीशन को निकालना था। पोजीशन सी हमें पता नहीं थी, उसे हमने फाइंड आउट किया है। अब हमने सिनेरियो को थोड़ा सा चेंज कर दिया है। अब हमें पता है कि हमें पोजीशन सी पे पहुंचना है। लेट अस से यहाँ पे पायलट बोर्डिंग ग्राउंड है, तो हमने यहाँ से पायलट को पिकअप करना है। तो हमें पता है कि हमें A से C तक जाना है, ये ऑलरेडी पता है हमें, रेड कलर का जो वेक्टर है ये पता है। और अगर वो हम यहाँ पे करंट भी अगर हमें दे दिया जाए क्वेश्चन में कि ये करंट इस एरिया में एक्ट कर रहा है, तो हम अपना CTS निकाल सकते हैं। सो क्वेश्चन में चेंज आ गया। पहले CTS पता था, हमने CMG निकाला। अब हमें CMG पता है और अब हम CTS को निकालने की कोशिश कर रहे हैं। सो लेट अस सी।
So AC would represent the course that the vessel will have to make good and the distance that the vessel has to make good in 2 hours. Since A and C are the same points as in the previous discussion, therefore CMG that has to be done by the vessel is 091 degrees true and the DMG is 20.6 nautical miles. The current experienced by the vessel is same as in the previous case, that is setting south at 3.8 knots. The master wishes to know what course should the vessel set from A and what engine speed she should be doing so that in 2 hours she is able to reach her destination at point C. So basically everything is same. So we could consider this in the reverse order to what we had earlier done. Now vessel wants to reach from A to C, highlighted by this black line, and this is your track over the ground or the CMG and the DMG vector represented by 2 arrows. Now she experiences current setting south at 3.8 knots. So if we have to reproduce this triangle, that means I'll have to draw the current north of C. Though the set given in the question is south, but what we'll have to do is current, if we have to draw at C, we draw it in the opposite direction, highlighted by this black line now, and represented by 3 arrows pointing southwards as before. So now this is the CMG DMG vector, this is the current vector, each of them is for 2 hours. Obviously, then A to B vector would be the CTS and engine distance vector, and we get CTS of 070 degrees true, and engine distance of 22 miles in 2 hours. That means engine speed of 11 knots.
बेटा ये एक मेथड है CTS को निकालने का, ये मेथड है, इसमें हमने वही ट्रायंगल को यूज किया जो पीछे से हमने पिकअप की थी, बट इसमें अब हम एक चेंज लेके आएंगे। एक्चुअली चार्ट वर्क में हम ऐसा नहीं करते हैं, सो चार्ट वर्क में जैसा हम करते हैं अभी हम देखेंगे।
Now there is nothing wrong with this working mathematically, it's perfectly in order. But in chart work, we do not, I repeat, we do not reverse the direction of current. So if it was setting south, we would prefer to draw the current setting south only. And to achieve that, we change the point of application of current. So we apply current instead of C, we apply current at A, like this. At A, we have applied current for 2 hours, setting south, and drift of 7.6 miles. This gives us a point D. Now, if we join point D to C, as you can see, what we see here is that A, B, C, D is a parallelogram. Obviously, then A, B, and DC are parallel to each other and also equal in magnitude. So obviously, since it's a parallelogram, therefore, D to C represents the CTS and D to C distance represents engine distance in 2 hours. So the CTS is 070 degrees true, engine distance is 22 miles in 2 hours, giving us a engine speed of 11 knots. So in chart work, if we have CMG and we have to get the CTS, we would draw the current at the starting point of the CMG line and draw the triangle as the lower part of the parallelogram represents. Now, these two scenarios, one wherein we had drawn the triangle which is representing the upper part of the parallelogram, and the one representing the lower part of the parallelogram, these are two different possible scenarios at C, and accordingly the processes carry different names. One possibility could be that we are given the course to steer and we have to find the CMG. When the CTS is known and CMG is to be found, we refer to that as allowing for current. And whenever we have to allow for current, the triangle would be completed as represented by this triangle in the upper part of the parallelogram. That means we'll draw the CTS track, and at the final end point of the CTS track, or if you want to call it as the DR position, we shall be drawing the current at this point and completing the triangle as we had seen earlier to get the CMG and the DMG. The other thing could be that we are given the CMG and we need to find the CTS. In such a scenario, we call it as counteracting current. And when we have to counteract the current, the triangle shall be drawn as the triangle in the lower half of the parallelogram. When CMG track is given, the current will be drawn at the starting point of the CMG line. It will be drawn at the starting point of the CMG line, and the triangle will be completed as in the lower half of the parallelogram. So this is the difference, how the triangles are completed. One for allowing situation, other for the counteracting situation.
So have a good look at the diagram, beta. Let me know any doubts at any of the points.
No, sir, no doubts.
Okay, very good, beta. So this is what we had done in the last lecture also. So हमने इसको revise कर लिया है. Let us now proceed ahead.
Now, there can also be situations wherein on ship, a vessel wishes to estimate the current that the vessel is experiencing, or in exam, the current set and rate is to be calculated. If you look at this triangle, vector triangle, which we are already familiar with now, if you see Current is the vector joining the dr position to its fix. It's the vector joining the dr position to the fix. So as you can see in the vector triangle, direction from dr to fix is the set of the current. So in this triangle, you can see the direction from fix to dr to fix is the set of the current, and the magnitude of this vector, or the distance from dr to fix, represents the drift of the current during the interval for which the triangle has been made. Again, it's being repeated here that every vector of the triangle has to be for the same duration. So if this triangle was made for 2 hours, so this drift of 7.6 miles would be for 2 hours. That means the rate of current would be 3.8 knots. So we need to be very, very careful about this also, because this is part of some questions wherein they would expect us to calculate the set and rate of current. That means in such scenarios, we'll have to find out the dr and fix of the same time, and using the dr and fix, we can find out the set and rate of current.
So is this concept clear, beta? Dr to fix is the set and rate of the current.
Yes, sir.
Okay, very good.
Yes, sir. Clear, sir.
Okay, beta, very good. Let's proceed ahead.
Now let us appreciate the elements of the vector triangle, because a good understanding of the vector triangle will solve many of our problems. Let's review once again the 3 vectors involved in our vector triangle. The 3 vectors involved in our triangle are track through water, represented by CTS, and engine distance, which in this triangle is represented by AB. So AB is the track through water, represented by CTS and engine distance. Second vector is the current vector, represented by set and drift, represented by BC in this case. And the third vector is track over ground, represented by CMG and DMG, which is represented by vector A to C in this diagram. CTS vector represented by 1 arrow, current vector represented by 3 arrows, and course made good vector represented by 2 arrows. It's imperative that in this vector triangle, every vector has to be for the same duration. So whatever is the duration of one vector out here, all the vectors will have to have the same duration. Now, since there are 3 vectors, each having a direction and magnitude, there shall be 6 elements of the vector triangle. These elements are course to steer, engine speed, from which we get the engine distance, set and rate of current, from rate we get the drift of the current, CMG and SMG, from wherein you get the distance made good after you integrate them with time. To be able to complete the vector triangle, please remember, you need to have minimum 4 elements out of 6. So if you have to complete the triangle, please source 4 elements, minimum 4 elements, and then only the triangle can be completed. If you do not have 4 elements, then no way can you be completing the triangle. The missing 2 elements can be then read off from the completed triangle. What is the physics law used in this vector triangle? The physics law used in this vector triangle is triangle law of vector addition, which states that if the 2 sides of a triangle taken in the same order or same direction represent 2 vectors, then the third side of the triangle taken in the opposite direction represents the resultant of the 2. So if you see here, CTS and current vector, they are in the same order or same direction because both are clockwise. And the CMG vector is anti-clockwise. It's the third side of the triangle taken in the opposite direction. So the resultant of track through water and the current is the track over the ground.
So beta, just go through these points one by one in your mind. Let me know any doubts coming anywhere.
सर इसका क्या मतलब है? द मिसिंग टू एलिमेंट्स कैन देन बी रेड ऑफ फ्रॉम कंप्लीटेड ट्रायंगल।
ओके बेटा, ये ट्रायंगल जब हमें चार्ट पे बनानी होती है किसी भी क्वेश्चन में, मान लो ये ट्रायंगल हमने बनानी है, तो क्वेश्चन में हमें टोटल 6 चीज़ों में से 4 चीज़ें जो है मिनिमम बता दी जाएंगी। क्वेश्चन में वो हमें 4 चीज़ें बताएंगे, वो कोई भी 4 चीज़ें हो सकती हैं। अब जब आपको 4 चीज़ें मिलेंगी तो आप इस ट्रायंगल को अपने चार्ट पे प्लॉट कर पाओगे। और टोटल 6 चीज़ें हैं इसमें, सो 2 चीज़ें मिसिंग थी जो क्वेश्चन में उन्होंने हमें नहीं बताई। वो 2 चीज़ों को हम ट्रायंगल बनाने के बाद चार्ट से पता कर सकते हैं, रीड आउट कर सकते हैं।
ओके सर, जैसे कि उसमें CMG एंड DMG।
हाँ बेटा, अगर आपको CMG और DMG नहीं दिया है, उन्होंने ये 2 चीज़ें नहीं दी हैं, तो आप ट्रायंगल कंप्लीट कर लोगे और कंप्लीट करने के बाद ये दोनों चीज़ें चार्ट से आप रीड कर लोगे।
ओके सर, गॉट इट सर।
ओके, और बताओ बेटा, और डाउट?
क्लियर सर।
Very good beta, let's proceed ahead then.
Now let us understand.
Okay. बेटा, जो नेक्स्ट कॉन्सेप्ट है, अभी हमने करंट का कॉन्सेप्ट जो है वो कंप्लीट कर लिया है। नेक्स्ट कॉन्सेप्ट जो है ये विंड का कॉन्सेप्ट है। सो व्हाट इज द डायरेक्शन ऑफ द विंड, व्हाट इज द लीवे, हाउ टू अलाउ, हाउ टू काउंटरैक्ट। सो अब मुझे ये बताओ, हमारे पास अबाउट 7-8 मिनट बचे हैं, और you want to continue with the wind effect now, or is it okay, shall we continue, or you want to keep it for the next lecture?
Continue, sir.
Very good beta, let's continue.
Wind and its effect on the ship's track. Wind is a continuous directed flow or movement of atmospheric air because of different atmospheric pressure over different regions. Direction of the wind, the direction from which it comes. That is, northerly wind means wind is blowing from north towards south.
अच्छा बेटा, अगर मैं बोलूं कि नदरली विंड है तो इसका मतलब है विंड इज कमिंग फ्रॉम नॉर्थ। अगर मैं बोलूं नदरली करंट है तो उसका क्या मतलब है?
विंड इज सेटिंग टुवर्ड्स नॉर्थ। नदरली करंट का बोलेंगे तो सर द करंट इज कमिंग फ्रॉम साउथ।
वेरी गुड बेटा, सो इस चीज़ का ध्यान रखना है, यू शुड बी वेरी वेरी क्लियर इन योर माइंड। विंड की डायरेक्शन हमेशा वो डायरेक्शन होती है जहाँ से विंड आ रही है, और करंट की डायरेक्शन हमेशा वो डायरेक्शन होती है जहाँ करंट हमें लेके जा रहा है। ओके, ऑल क्लियर?
यस सर।
वेरी वेरी गुड बेटा।
So please remember, the convention used for naming the direction of the current is opposite to the convention used for naming the direction of wind. Wind affects the ship's track through water as well as over the ground. The track through water allowing the effect of wind is referred to as effective course or leeway track. So once we allow for wind on the course that the ship is steering, the track that you obtain will be referred to as effective course track or the leeway track. Angle between the course to steer track and the leeway track is referred to as leeway. In chart work, effect of wind on ship speed is intentionally left out because of limitations on number of elements of the vector triangle.
So beta, just go through these points. Let me know your doubts in any of them.
सर लास्ट वाले में से चार्टवर्क विंड ऑफ इफेक्ट शिप स्पीड इज इंटेंशनली लेट आउट का मतलब क्या है सर?
ओके बेटा, बेटा इसका मतलब ये है कि जब भी हम चार्ट वर्क में विंड को कंसिडर करते हैं, किसी क्वेश्चन में हमें उन्होंने विंड दे रखी है, तो उस विंड की वजह से हमारी स्पीड में कोई फ़र्क नहीं पड़ता है। जब भी हम चार्ट वर्क करते हैं, ये चीज़ हम मान के चलते हैं कि जितनी भी विंड हो, उस विंड से हमारी स्पीड पे कोई फ़र्क नहीं पड़ता है। स्पीड रिमेन्स अनचेंज्ड, ये मतलब है बेटा।
ओके सर, स्पीड में कोई इफेक्ट नहीं है।
राइट, विंड का इफेक्ट जो है ये स्पीड पे नहीं आएगा चार्ट वर्क में।
ओके सर।
Okay, let's proceed ahead.
However, practically, it may not be of much concern for the simple reason that very seldom would we have wind alone and no current. Because if the wind blows over the surface of sea for some time, the least it would give rise to are the frictional currents. So when wind and current often coexist, so even if the effect of wind has not in isolation been considered, it will automatically show up when the current is estimated, and as far as the ship is concerned, it will be taken care of. So that is if they coexist. However, if you talk of a hypothetical situation where there is only wind and no current, then yes, the effect of wind on the speed of the ship in chart work is intentionally left out. But again, I would say in practical considerations, it may not be a serious omission. Allowing wind is the term used when we know our CTS and we are required to find our effective course or the leeway track after factoring in wind. How do we allow for wind? Let us see it through a simple illustration. The vessel is at position X, is steering a course along XY track, experiencing wind which is southerly as shown by the wind arrow. Now we have to allow the given leeway. Now the leeway, when you allow for wind, the leeway must be allowed to the lee side of the vessel or should be allowed downwind, whichever way you're convenient, it's comfortable for you to remember. Now in this case, the wind is blowing from the starboard side of the vessel. So the port side of the ship is the lee side, or the starboard side is into the wind side and port side is the downwind side. So whichever way you are comfortable, you may remember it. So in our case, the leeway shall be applied downwind as shown in the diagram. This is applied on the downside or downwind side or lee side. And this track XZ that we are getting is the effective course or the leeway track. The magnitude of this leeway track shall be engine distance, which in the absence of wind was the magnitude of the CTS track.
So beta, is this clear?
Clear,
जो
sir.
लीवे ट्रैक होगा उस पे भी एक ही एरो लगाएंगे सेम लाइक सीटीएस?
यस बेटा, CTS का और लीवे ट्रैक का या इफेक्टिव कोर्स का एक ही सिंबल है, दोनों को हम सिंगल एरो से ही शो करते हैं।
फिर सर आइडेंटिफाई कैसे होगा कौन सा क्या है?
ओके बेटा, वो इसलिए नहीं ज़रूरत पड़ेगी क्योंकि नॉर्मली चार्ट वर्क में हम लोग CTS को शो नहीं करते। जब भी कभी विंड होती है ना, तो हम सिर्फ लीवे ट्रैक को ही शो करते हैं, CTS को चार्ट प्लॉट पे शो नहीं करते हैं। अभी सिर्फ आपको समझाने के लिए हमने ये दोनों बनाए हैं, बट एक्चुअल प्लॉटिंग जब हम करेंगे तो CTS को चार्ट पे शो नहीं करेंगे, सिर्फ लीवे ट्रैक को या इफेक्टिव कोर्स को ही शो करेंगे, तो कंफ्यूजन नहीं होगा।
बट सर सीटीएस को ड्रॉ नहीं करेंगे तो मैग्नीट्यूड कैसे आएगा सर?
बेटा CTS मैग्नीट्यूड में तो कोई फ़र्क ही नहीं है, CTS का भी मैग्नीट्यूड उतना है, लीवे ट्रैक का भी मैग्नीट्यूड उतना है, तो मैग्नीट्यूड में तो कोई डिफरेंस ही नहीं है।
Okay, sir. Okay, sir. Okay, sir. Got it, sir.
ओके, सो इट इज़ बेसिकली हमारा जो शिप है वो XY ट्रैक पे चल रहा था, हमें सदरली विंड मिली जिसने हमें पुश करना शुरू कर दिया। तो उस पुश करने की वजह से शिप अब X to Z वाले ट्रैक पे चल रहा है। हेडिंग हमारी X to Y डायरेक्शन में ही होगी, लेकिन हम चलेंगे X to Z ट्रैक पे। इस ट्रैक को लीवे ट्रैक या इफेक्टिव कोर्स बोला जाता है, और इन दोनों में जो एंगल होता है उस एंगल को हम लोग लीवे एंगल बोलते हैं। ओके बेटा, क्लियर? हाँ बोलो बेटा।
सर ये सीटीएस एंड ट्रू कोर्स स्टीयर्ड दोनों अलग अलग चीजें हैं सर वैसे तो।
नहीं बेटा, CTS और ट्रू कोर्स स्टीयर्ड एक ही चीज़ है, इनमें फ़र्क नहीं है। अलग अलग सिचुएशन में अलग अलग नाम को यूज़ किया जाता है, मैं आपको बताऊंगा, पर है ये दोनों एक ही चीज़।
सर सर टू स्टीयर एंड स्टीयर्ड तो अलग ही हुआ ना सर, मतलब स्टीयर
ओके,
करना था वो, लेकिन
हाँ बेटा,
किया वो तो अलग ही हुआ सर, ये तो ये सेम कैसे हो सकता है?
ओके बेटा, ओके। देखो बेटा, ऐसा है, अगर तो आप अलाउ कर रहे हो, लेट अस से आपको उन्होंने बता दिया कि आप 090 का कोर्स स्टीयर कर रहे हो, ठीक है, और ये 090 का जो कोर्स है हमारा कोर्स स्टीयर्ड बन जाएगा, करेक्ट है बेटा? अब आपको उन्होंने सिचुएशन चेंज कर दी, उन्होंने बोला है कि आपको एक पर्टिकुलर डेस्टिनेशन पे पहुंचना है, ये करंट है उस एरिया में, काउंटर एक्टिंग वाली सिचुएशन आ गई। अब काउंटर एक्टिंग वाली सिचुएशन में अगर आप ट्रायंगल को सॉल्व करोगे तो जो आंसर आपके पास आएगा उसे हम कोर्स स्टीयर्ड तो नहीं बोल सकते, क्योंकि शिप तो अभी चलना शुरू नहीं हुआ है, वो तो जब आप कैलकुलेट कर लोगे उसके बाद ही चलेगा ना। तो हम उसे बोल देते हैं कोर्स थ्रू स्टीयर, CTS। ये फ़र्क है दोनों में। अगर शिप ऑलरेडी ट्रैक पे चल रहा है तो उसे कोर्स स्टीयर्ड बोल दिया जाता है, और अगर हम प्लॉटिंग से फाइंड आउट करते हैं कि कौन से कोर्स पे हमें चलना है तो उसे CTS बोल दिया जाता है। दोनों का सिंबल एक ही है, सिंगल एरो के साथ हम इसे शो करते हैं, और ट्रायंगल में दोनों की लोकेशन पोजीशन बिल्कुल सेम है। समझ गए बेटा? इज इट क्लियर?
सर
ओके, सो अप टू हियर एनी डाउट्स?
नहीं सर।
ठीक है बेटा, अब हमारा टाइम हो गया है। शैल वी ब्रेक इट ऑफ हियर और यू वांट टू कंटिन्यू?
सर नेक्स्ट लेक्चर में स्टार्ट करते हैं हम।
ठीक है बेटा, ओके, ऑल राइट। Okay, so next lecture we will continue exactly from here, the effect of wind. So today you did a very important topic, so very good. So see you in the next lecture then. Till then, bye bye.
Okay, thank you. Bye bye, sir.
Okay, thank you, bye bye.